Okay, here we go. So we just got done graphing the r equals 1 plus sine theta. We got that it was a cardioid. And now we want to find dy dx. However, we do not have an x or a y involved in our function here, our polar function. So we're going to get them involved. So we have to use what we had when we converted from polar coordinates to rectangular coordinates. So here we go. These are the equations we had. X equals r cosine theta and y equaled r sine theta. Okay, so then all we're going to do is substitute what r is, because in our graph we know r equals 1 plus sine theta. And that's all we're going to do with that. 1 plus sine theta, sine theta. Okay, now dy dx, that's what we're trying to find. So just like in our parametric equations, we're going to write dy as dy d theta and dx as dx d theta. Okay, now we can find dx d theta with our substitution that we just made. We have it's a product right at the moment, so we got to use the product rule. We're going to take the first times the derivative of the second plus the second times the derivative of the first. Okay, we got the derivative of cosine is negative sine, and the derivative of 1 is 0, and the derivative of sine is cosine. So there we go. I'm going to distribute. So we got minus sine theta minus sine squared theta plus cosine squared theta. Now you might think that we could cancel, well, use the trig identity, sine squared plus cosine squared equals 1, but they're opposite signs, so we can't do that. Let's find dy d theta. We've got to use the product rule again. So we got the first times the derivative of the second, which is cosine, plus the second times the derivative of the first. The derivative of sine is cosine. Here we are. So then I'll distribute. So we got cosine theta plus, and we got 2 sine cosine. There we are. So if we're finding our derivative like we did, we got up top is cosine theta plus 2 sine theta cosine theta all over what we got for our dx d theta, which was minus sine theta minus sine squared theta plus cosine squared theta. There we are, and that's what we were looking for. In the next video, we'll see why this would be helpful.